Cloud. Hello, everybody. Welcome to the January 2024 Happy New Year, everybody, meeting of the Howard Astronomical League. I'm going to bring up the slides now, if I can, and share my screen. Can everybody see the title slide for the briefing? Yes. Okay, terrific. Okay, well, we have a really full meeting, so I'm gonna, is there any way to make the lights like a little dimmer? So here is the agenda for tonight. We're gonna have some introductions, do some club business, including an election for this next year's board. Have a couple of announcements, and then our own Grace Coventry is going to speak about some exciting new stuff in the smart telescope world. And then we'll do our regular features of what's out in the sky and then go through some images. So first off, are there any new members who would like to say hello or introduce themselves?
I'll say hi, I'm Jason Harmon. Just joined on your site a couple weeks ago.
Okay, great. Welcome to the club, and welcome to being here in person too. I appreciate you coming out in the cold and everything. When we're speaking, for folks on Zoom, when we're speaking, do you see our view?
Yeah, we can see the audience. Yes.
Okay, so it's in the other little window, but not in the. Oh, okay.
It's in the normal Zoom window.
Grace has the thing up. All right, this thing is automatically changing slides, which has got me scared because I don't know if it's on timer now. But well, welcome, and I'm glad you're here. And hopefully this, you'll get some, good stuff out of the club and enjoy it. So, and this is a good meeting to come to as your first one, because you're going to get now a quick snapshot of everything we did in 2023. So, Joel, are you on?
Yep, just made it back in town. Here I am, and couldn't make it down to the center, but did make it here. And that is our end of the year balance. I'll talk a little bit about that in just a minute, but that is how much money was in the bank at the end of December. Next. And here I'll just leave this up for a moment because there might be any questions, and you'll see our different categories of spending and income, and comparing 22 with 23. As you can see, our income with dues. Oh, actually,
It's on some kind of timer.
Yeah,
I don't know how I did that.
So you can see our income with about the same. You're going to see our membership numbers in a moment, and pretty much an even membership. And then as within the spending, about the same, because we made some other observatory upgrades, the same as we did in 2022 following the pandemic. And I'll go to that. And there's what we did spend. Those were our big ticket items from last year. And there's all towards the end of the year, I believe, a new computer we needed for the to running Halo more efficiently, and with the new softwares that we have, the Seestar, which you're going to hear about in just a moment, a few minutes, with a dedicated iPad. Sorry about that, Victor.
It's not automatic. You turn it off in PowerPoint.
I don't know how to make it stop automatically switching slides.
Yeah, you have to go out of the presenter mode. Then you have to go up to the top to I can show you.
Hi, Phil.
Hey there. Are you in PowerPoint? You could just shrink, bring up PowerPoint.
This
Is
is
this a
PowerPoint.
PDF or is this just?
No,
PowerPoint?
this is PowerPoint right here.
Okay, so.
I just have my
go to review. And then, yes. That's here. It's right, pull that down so it doesn't go away. Oh, go to
so it's the ribbon. I hid the ribbon because I was trying to be clever.
And that's for PowerPoint, that search?
Yeah, that's PowerPoint.
Just type in there, stop slideshow. Or, yeah, something like that. Slideshow, I'll say. And you click on it.
Loop continuously.
There you go. I think we're good.
Okay.
Are you guys back in, into?
Yep. Yeah, go back one slide. And so you'll hear more about the Seestar in a few minutes, and that iPad is an accessories to go with the Seestar, and I'm sure Grace is going to share all those alternatives with us. Next slide. Our membership numbers from the end of 22 to the end of 23, you see a slight increase in memberships. I tend to go, and I shared this last board meeting, the members number being 385. I think our members is actually larger than that, because when people register online and they register as a family membership, register as a family membership, they have the option to put in the other family members. And I believe we have larger families that are certainly not putting all their children's names in our database for the most part. And that's, I believe, it. If there are any questions, comments? Oh, actually, leave on that slide right there. We started tracking a number of years ago, just seeing the individual memberships and what our percentages are. And going back to Pro, at some point, Ken may share this at some point. Last year, he showed a graph showing in the last like 7-8 years how we went from much higher than 54.8% of individual memberships. And now we're pretty much a 50-50 club as far as families and individual memberships. That's about all I have. If there are any questions.
Yeah, Joel, I think you just kind of explained what I was going to ask. For those who don't know the difference between memberships and members, why that's a different number. Maybe you just want to explain what that is.
Yeah, is it when if Victor, I think, has a family membership, when he signed it up, he may put in a family membership and may only put in his name, as opposed to putting in his wife and 2 daughters' names. He doesn't have to add in any other names when he's registering. So I guess it's just people's, so our memberships is certainly how many families and / individuals who are committed to HAL with dues paying. Our members is significantly higher, I believe, than 385. Does that answer your question or elaborate?
Yeah, that's great. Perfect. Thank you.
Yeah, and then just to elaborate, a single individual membership is $25 a year, which has not changed for, I don't know.
Ever.
And then if you want a family membership, it's $30 a year.
Right.
And then you can sign up as many people. And I do, in my case, I do believe I signed up my wife and 2 kids. So there's 4 of us, but maybe not like you said.
And so if you go back just a minute, because it gives everybody an idea how the club is running. One more back, keep going back to the so as you can see, with about 300 members and with PayPal expenses and things like that, I always put because we have families and individuals, that we average $25 per membership. So if you do the math there, that's $7,500 of income, and that's going to be pretty consistent going each year. As you can see right now, we have that bank balance of more than that. We always keep at least what is the annual expenses is the key of it in a nonprofit. But the rest of it, the board each month discuss how to utilize the other funds we have to make HAL a better club. So that also comes, I'm reaching out to whoever's on Zoom or in the room too. That's also from the membership too. It's how we can better improve the club. So I mean, some of the things have been talked about before. We're a 20-year-old club of sponsoring a scholarship for an astronomy student. I'm just throwing things out there, but there are lots of things that we can do as a nonprofit. The idea is not to have a big bank account. So that's all I have to say. Victor, any questions or comments? Otherwise, I will mute and we'll go on.
No, thank you very much. And if you've noticed, the big expenses were observatory, because we upgraded some of the equipment and the telescope on the ILIG scope and the display and whatnot. Last year, we upgraded the laptop with help from our second VP / IT expert who understands computers better than a lot of us. Grace helped us pick out a laptop. And this coming year, I've already it's like 4 days into the year, I upgraded the display monitor that's in the observatory. So that will be one of the big expenses for 24. But it was only like it's like 1K for an ATV.
Question?
Yes.
The observatory expenses, is that basically hardware as opposed to utilities or heating, or it's just hardware for like the facility?
Yeah, it's
Books or?
Yeah, yes. The answer to that is all and I went back and really kind of cleaned up my categories this year. That's pretty much hard things. If computer went into a computer category, I believe, is down below. That would be HAL equipment, and the observatory is telescope things. And we had really virtually no other expenses because we don't do other things outside of our observatory.
well, you can see what mailbox, website
Right.
fee,
Yeah.
Insurance.
Right, and the question, Joel, was really around other things like electricity and stuff like that.
No, we lease that building at $0 per year from Howard County through Recreation and Parks. The little bit of electricity we use, we've never seen a bill for. That's the same thing as the park lights. We don't have an internet account there because we've used people's hotspots when that has been needed. Verizon has made that not very easy to do. The fact that we are a nonprofit, the fact that it isn't a park, makes absolutely no difference at all. We would be paying top dollar, actually more than you pay at your home.
Okay, so let's move on. That was the money stuff. The State of the Union is good. Membership is the hobby is still very much interesting to lots of people are joining, and it's amateur astronomy is alive and well. And so now what I thought I'd do is just quickly go over the not the finances, but but some of the things that we did in 2023, just to review the last year since it's the start of the new year. So we had some excellent speakers from Applied Physics Lab and Space Telescope and NASA. And all of these presentations are recorded on our Zoom, on our we recorded on, and they are up on our YouTube site, the Howard Astro YouTube site. So we had some really awesome speakers last year, and that was super fun. And I'm hoping that we'll have another good year. I'm reaching out, and if anybody knows somebody works in in this business and knows somebody who's interested in outreach, please let me know. Next, I would also like to thank our members who regularly contribute to the meetings. I said thank you to our meeting regular. They're not regular, they're special, but they contribute regularly. So that would be Jim Tomney, Wayne, and Phil. And also thank you to our librarian, Crystal, who has she's kind of injected new life into the library of the observatory. I've read a few of these because I would have never come across them without her recommendation. So thank you. And then lastly, thanks to all of our members, because that's what it's all about. This club is about outreach, really. And I mean, it's about us learning and doing things and enjoying astrophotography, but it's also about STEM and sharing, sharing knowledge with the members of the public. And we had, the weather didn't cooperate as usual for several of our star parties last year. But when it did, we had excellent turnouts, 150, 200 people regularly. And there's Phil leading a big group on the solar system walk in the bottom right corner. So yeah, thanks to everybody for doing that. So that's kind of a quick review. And then at this point, maybe it's kind of self-serving to talk about how good last year was right before I asked to be reelected. But I'll turn it over to Jim for the election stuff.
Thank you, Victor. So at the time of year is rolled around once again, it's time to elect the board of directors for the 2024 term. Let me just go over how I'm going to do the election this time. We're a split audience. We have people in the Robinson Nature Center in the room. We have people online, and what I'm going to do is go to the room first with but first, let me say that we have exactly one candidate for every board seat, and we'll do that all in one vote. I'll take the vote from the room first. Ayes and nays.
Yeah, you want to put up the, you have the screen with the candidates there? Victor?
I was going to get to that in a second.
Oh, okay, sorry. That's
So I'll do the voice vote in the room first. I think I see 3 or 4 people there, maybe 5.
There are 6 in the room and there are 33 on Zoom.
Okay.
we're one of them.
Oh, minus
And-
1. Yeah, sorry.
And online, I'll just do a show of hands and I'll just flip through and count real quick to see how many are there for the ayes and for the nays.
2 for the Savoy family.
Let me, and just a word on the members and memberships that was discussed a little bit ago. It's 1 vote per membership. So if you're a family, just need to see 1 hand for the family. And with that, next slide, please. Here are the candidates. Victor Sanchez running for a 2nd term as president. Jim Tomney, I think this will be his 3rd or so term on the board. Grace Coventry, 2nd vice president, her 2nd term, I believe. Atul Agrawal will be his 2nd term as secretary. Treasurer Joel Goodman. I've lost count of how many years he's been on the board.
On the board a long time, I think 4th year as treasurer.
Okay.
5th.
And the only person not running for a repeat term is Richard Wren, who is the off-going events coordinator. David Stein is coming back to the board, I think, for David's 3rd time on the board that I know of. So with that, from the room at Robinson Nature Center, all in favor of this slate of candidates, aye?
I We got
And-
6 ayes.
What's that?
Sorry, you got 6 ayes from the room.
Okay, so that was everybody, so no nays. And if your vote is aye, if you're online, just raise a hand and I'll just, oh, look at that. And if your vote is nay, raise a hand. And I don't see any hands. So there you go. There's your 2024 Board of Directors. Thank you guys for serving last year and in the past and serving again. And I believe that's all I have. Thanks, Victor.
Okay, terrific. Thank you.
Thank Jim for,
Jim,
Running the election.
as long as we're talking about how many years people have been, is this like your 4th or 5th year running the election? So, I mean, since you stepped down as president, I think you've been doing
Well,
this.
Since we have counted for Phil Whitebloom's last year, that was 4 years, and for your 2 terms, so 6 years I've done the elections.
All right, well, thank you for that, and I hope you continue
You're welcome.
to stay engaged. Okay, so moving on to the agenda. Next, we'll go into a few announcements. First is our star parties, and we have I just circled the one that's coming up the soonest. It's not until March, as we just need to wait for it to warm up a little bit. So those are the dates. They're up on the website if you if you forget or you want to double check as the dates approach. We'll
That-
make.
It should say 2024, right?
Thank you. That was I put one typo in all of my presentations to see if somebody will catch it. You get the prize this time.
I'll go back to sleep then.
Yeah, your prize is you're allowed to use the Seestar at a star party. Thanks, thank you. Those are the 24 dates, and then the other event, there'll be some special events this year, like there's International Observe the Moon Night, and we'll see we'll stay tuned as things go on. But the one that came to mind when I was making this chart was the obvious one, which is the eclipse. Or if you want to get technical, we had a speaker last year about occultations. It's an occultation. It just happens to be our moon that's occulting our own star. But anyways, there's no official HAL event. There might be some unofficial day trip stuff, so stay tuned for that. And the other thing about the eclipse is that HAL has, I forget how many, 100 or 100 eclipse glasses that are for the club. So this is incentivization to come to the next couple of meetings, because we'll be distributing glasses nominally. We'll see how they hold up, but nominally 2 per member, or if you're a family membership, maybe more or whatever. So stay tuned for that. And we're also probably going to have a little more. Jim Johnson has a interesting set of presentations that he's put together for discussing past eclipses, and he's going to summarize at the May meeting. But we'll also maybe have him come in, depending on what other speakers we get, speak a little bit about this year's eclipse in February and/or March. So, okay, and this is our eclipse path. This tells you how far you're going to have to drive if you want to do a day trip to achieve totality. Yeah, and that's just it. This is just you Google 2024 solar eclipse, and that and other interesting things will come up. So, Crystal, would you like to?
Yeah. So for those of you that are joining us, as Victor mentioned, I'm the librarian, and so to start us off, in 2024, this was actually a holiday present, so I was really excited to read it. So today's book of the month is Exoplanets by Donald Goldsmith. So prior to the discovery of exoplanets, which is often preferred over the term extrasolar planets, everyone from science fiction writers to the leading theorists of the time imagined that planetary systems would resemble our solar systems, which means like the rocky, smaller planets would be towards the center, and you'd have your larger gas ice giants towards the outer edge. Now, the author is an experienced astronomer who explains how the detection methods have kind of evolved over time and even synced together to lead over to 5,000 confirmed exoplanets as of today. And, I'm a little biased. I personally love this story because while there's some debate over the first exoplanet officially, the announcement of 51 Pegasi b coincides with the year that I was born, 1995. So I feel like I've kind of grown up and been along for the journey of this new branch of scientific discovery. And the first hurdle to really grasping worlds beyond our own is that the sheer size of cosmic distances. So Goldsmith does a great job giving the reader an appreciation of how difficult it is to, air quote, see an exoplanet. So to see a planetary body in the glare of a host star, and why this initially led astronomers to more indirect methods to study the effects of exoplanets on a star rather than trying to detect them directly. I'd also say that the book does an excellent job of introducing the different ways of finding exoplanets. There's a little history of telescopes and the missions that are involved, and what advancements would be needed in the future to kind of continue that search. I place it at a mid-level difficulty only because the graphics and sometimes the vocabulary might slow a reader down in certain places if this is like your first trip into astronomy. Overall, it's a great read. It's very easy, it's phenomenal. I think it just really encourages everyone to really ponder that possibility of habitable worlds beyond Earth. So I'm a little bit a sucker for exoplanets, so I highly recommend it. It's a short read. It's only 272 pages. So a great book for an easy afternoon, maybe a snow day book.
Oh, great. Thank you. I think it's going to be one of my snow day books. Maybe tomorrow.
Boy, when Crystal said she was born in 1995, I was gonna see if she had to get a note from her parents to be up this late.
I know for some people I'm sorry about that.
Our next speaker was also born in 1995.
Thank you.
Okay, so now we'll have Grace give her presentation, which is titled Seestar S50, the next generation of smart telescopes. Grace is the head of the IT service division at the Space Telescope Science Institute. She's, as already mentioned, our second vice president and will continue to be in 2024, yay. And so this is her presentation. So with that, I think I'm gonna stop sharing and let Grace share her screen.
Right.
Did I stop?
I think so.
Oh, I think I stopped the wrong thing. Hold on.
Stop Zoom.
Can Zoom still see everything?
Yeah, we see you mousing around on PowerPoint there.
Thank you, Dale.
Looks like Grace's.
Yep, Grace's is there.
You can see my screen now?
Yes.
Pretty blue.
Okay, let me see if I can share it full screen and see how that works.
I see it on my screen here.
Yeah, if you just change the one that's,
There you go. You're full screen now on Zoom.
Perfect. Okay,
yeah, almost.
just give us 1 second. here.
There we
Perfect.
go.
Okay, everybody hear me okay? See me okay?
Yeah.
Excellent. So, well, welcome everybody, and I'm really appreciating this opportunity. As Victor mentioned, my day job is with the Space Telescope Science Institute in Baltimore, with which many of you are familiar, and indeed at least one person in this meeting other than me is employed there. Shireen. And there's a long history of collaboration and working together, and I'm glad we have an opportunity to do so here. So a little bit about me. I joined STSCI about 3 years ago after a long career in IT and other domains. I had no background in astronomy at all. I did a telescope, had an amateur interest in astronomy, but I'd never really done much with it. But then I joined the Institute, and suddenly I was working with hundreds of people who actually are world-class professional astronomers. And in light of that, I thought I should start learning the lingo. So I figured there was 2 ways I could do that. Number one, I could go to university, get a PhD and then a postdoc, spend 10 years and then several hundreds of thousands of dollars and get some street cred that way. Or I could buy a digital telescope. So I decided to take plan B, which is buy the digital telescope. At the time, the only ones that were available were the Unistellar EV scope, which is the one that I got, and a telescope from a company called Vaonis. I'll talk a little bit about how the Seestar compares to that generation of digital telescopes as well. But that was really my introduction to astronomy. Then by extension, a few months after I got the telescope, I joined HAL. So it was really an entryway, I think, as you'll see, for a lot of people with these smart telescopes to astronomy, to people who otherwise might not pursue it at all. And we'll talk a little bit about kind of what that means here. Tonight's talk is specifically about a brand new entrant into the world of smart telescopes from ZWO, a company you may know makes principally astronomy cameras and accessories and so on. Well, they decided to get into the telescope business as well. And late last year, they started shipping a product called the Seestar S50. Over here, if you can see me on the camera here, I have the Seestar set up, so you can see it's actually quite compact. It's a very small unit. So let's get started. So what are we going to talk about tonight? Well, first of all, I'll spend a little while talking about what the whole paradigm of smart digital telescopes, the Seestar, the EVscope, and others, is. What makes it so different? And part of that is, how do they navigate an image? I'll talk a little bit and give some examples of that. We'll talk about kind of the examples of the evolution of smart telescopes, which the Seestar and others are starting to represent. Then I'll talk specifically about some details about the Seestar itself, give you an overview of its specifications, and then walk through the various observing modes of the telescope with some sample images. I'll also talk about, once you sort of collect images from the Seestar, what can you do with them, and give you some examples of image post-processing. And then we'll talk about some bigger picture stuff. I'll give my appraisal of the strengths and limitations of the Seestar as a telescope. Other people may hold different views, but it might be helpful for those of you who are considering whether you'd like to acquire one. And indeed, a number of HAL members we're aware of have already acquired Seestars, and I believe more are on the way. We'll talk specifically about how HAL intends to use the Seestar we've acquired. We've had discussions about that at the board level, and we'll share that with you. And then some final thoughts, and I want to make sure we leave some time for Q&A as well. So on the right here, you see an example of an image that I took with the Seestar of the Andromeda Galaxy. Since anytime you buy a telescope, the US Constitution has an obscure clause that demands you first image Andromeda. So there you go.
Oh, after the clouds go away.
Yes, yes. And after that, you have to do Orion, but you already know that joke. But anyways, okay. So what is a smart digital telescope? Well, it means some pretty specific things, right? What we're talking about are devices that are fully integrated in general. It's not like you purchase a separate mount and you purchase a separate optical telescope, optical tube assembly, or optical telescope assembly, and a separate guide scope and a separate camera. No, it comes as a single unit. So it's one form of electronically assisted astronomy, or EAA. It just happens to be highly integrated. So it does a lot of the hard work for you, right? It locates objects in the sky. It tracks those objects without requiring you to have a computer or sort of master the intricacies of polar alignment or purchase an equatorial amount or do any of those things. So as a result, they're incredibly fast to set up and start using, which is one of the benefits we'll talk about. They are not equatorial designs. They are, like the Seestar, all azimuths, right? So they don't rotate as the Earth rotates across the night to track the objects. Instead, they use a technique called derotation, digital derotation. I'll explain what that means a little bit later. They're controlled by a mobile app. And so we, in fact, have purchased for HAL an iPad that we can use at parties and so on, where people can use the application and see images as they go along. And the app and the device typically have a large built-in star catalog, so you don't have to know where M42 is located. All you have to do is type into the app M42, or look through today's preferred choices, or what have you, and up it comes. It really doesn't require a lot of advanced knowledge about astronomy, which is one of the appeals to it. I'll talk more about derotation and stacking in a little bit. One thing to understand about this is that it differs fundamentally from optical telescopes in this way. There is no optical eyepiece. In other words, if you're looking at M42, the photons are not going through the telescope directly to your eyeballs the way they would with a traditional optical scope. Instead, they're intercepted by what is essentially a camera sensor. And the camera sensor then takes the image and then it beams it down to your mobile device using Wi-Fi or Bluetooth. So it's a bit of a different paradigm that way. Typically, they're powered by a rechargeable built-in battery, so you can take it outside and use it freely. And they range in price from about $500, which is where the Seestar comes in, up to the high end, give or take $5,000. So there's a pretty dramatic range of prices for these types of products. Okay, so that's the paradigm. So let me talk for a second about how smart telescopes navigate. So those of you who already do astrophotography and use equatorial mounts will be very familiar with this process, since you're already doing this using, probably some fairly complex software and hardware. So essentially the question is, how does the telescope know what it's looking at? Well, it really it does a few things. First of all, it has GPS built in. So it actually knows its celestial coordinates when it's looking up at the night sky. Then, essentially what these telescopes have, to put it in very simple terms, are built-in maps, built-in atlases of the night sky, of various objects. And then, when it looks up at any sort of random patch of clear night sky, it can look at the geometry and the relative brightness of objects it sees in an image and compute from that, oh, that must be this patch of sky at these celestial coordinates. So essentially, it's kind of like you looking at a map of the United States and going, oh, that rectangle must be Wyoming. It's sort of a similar concept. And it does, and the term for that in astronomy is plate solving. So for those of you who aren't familiar with the terms plate solving or plate stacking, at the inception of astrophotography, images weren't even taken on celluloid film. They were taken on glass plates that have been sprayed with a photosensitive coat. And so you'll often hear people use the term plates. Plate solving means identifying what you're looking at by virtue of what you see in the image, and plate stacking, sort of, I'll get to that in a second as well. So that's really what it does. And then once the telescope has oriented itself, it knows what it's pointing at. You can type in the app whatever you want to look at, and then the telescope can compute the difference and say, okay, well, I need to slew 47 degrees in this direction and 22 degrees in this direction to find the object, and then it sort of compares what it sees against its built-in database, then fine-tunes it until the image is perfectly centered within your telescope. So it really uses a series of linked and coordinated technologies to solve the problem of, I just want to turn on the telescope and go look at something. This is how it does it. First of all, the telescope figures out what it's looking at now. Then you tell it what you want it to look at, and the telescope takes care of the rest. Okay. So then when it's done that, and you're actually pointing at something, how do these telescopes image? And there's really sort of three key technologies that are at play here. The first one, as I said, is called plate stacking. So what this means is the telescope doesn't take a single image of an object like Orion or something like that, which is what you see an example of here. Instead, it keeps taking images over and over and over at fixed intervals. And with the Seestar, you can be 10, 20, or 30 seconds. And you can let it run essentially for as long as you want, or at least for an hour, 2 hours, or more. And essentially, the telescope sort of stores each of those individual images called subframes, and then behind the scenes, it does some digital magic. And specifically, what it does is it creates a clearer and brighter image by combining those individual subframes to get rid of the noise that's caused by random variations in the camera sensor or light pollution or things like that. And it also takes care of the problem, which is a common one in astronomy, where a satellite and an airplane might be crossing your path while you're attempting to take an image. The telescope recognizes it, and it drops those frames. So it doesn't incorporate those streaks, and you see an example of that here, into the final image. So already it's doing a lot to make the image look better. I'll give a specific example of that with real world pictures here in just a minute. The second thing it does, because it's an all azimuth and not a equatorial mount, is it has to compensate for the fact that objects are rotating around the night sky over time because the Earth rotates. And so the way the telescope does that is that it digitally compares the images and the angles of them and essentially smooths it out. It digitally aligns them so it looks like they were always a single complete oriented frame. And what that buys you is then you don't have to worry about having an equatorial mount, balancing an equatorial mount, doing polar alignment, any of those things. Those are no longer in the picture. And then there's some other things. These vary somewhat by the kind of smart telescope, but in general, these are things they do in the background as well. They subtract the noise of the sensor, the camera sensor, because it has its own set of noise. If you ever heard the term dark frames, it's kind of the equivalent of the telescope taking a dark frame and subtracting the noise. They often have algorithms to reduce the ambient light pollution in the images. And finally, with telescopes like this, there's typically an option so that you can actually see the finished image with the metadata right there on the photo. What are you looking at? When was it taken? How long were the exposures and things like that? The telescope takes care of all of that. You don't have to. Go ahead.
With the derotation, do you get a lot of cropping?
It depends how long you do it. I would say I've done imaging for at least an hour on both the Seestar and the EV scope and iPad, and there's really very little observable cropping the image. Now, if you did it for a long period of time and you're doing an object that's close to the horizon for something, then you may well encounter greater degrees of that, but I haven't really noticed it to be a problem. In practice, derotation has its limits. I haven't been able to typically observe a lot of objects more than an hour or two, but then again, that just may be my ADHD kicking in. But in general, you're good after that. But there, I don't think you could take a 10-hour image with the Seestar without having during its derotation artifacts. But for an hour or two, which in general is about as much as you'll probably want to take in a lot of cases, it works fine. Did I answer your question?
Yes, thank you.
Okay. There's a famous quote from Arthur C. Clarke, which was, "Any sufficiently advanced technology is indistinguishable from magic." And I will say the combination of the telescope's ability to automatically navigate and locate and automatically produce pretty high quality images that you would otherwise have to employ some fairly sophisticated astronomy software to achieve, especially if you're somebody who's relatively new to the field of astronomy, it freaking feels like magic. And I can tell you at star parties, where I've used the EV scope in the past, I'll show, I'll be observing, I don't know, Omega or Orion or something, and they'll look at it, and some of the times they just look at me and go, "Come on, that's not real, right? This is basically a photo or something." I say, no, this is real, but it's so dramatically different than what they're used to seeing through an optical telescope that it can be hard to wrap your head around the first time. It's a pretty compelling paradigm, I'll say that. Okay.
Hey, Joel, sorry to interrupt.
Yeah.
With regards to the derotation and how much cropping, and actually related the length of your exposures, I think it depends a bit upon where your object is in the night sky and where you are on the Earth.
Yeah.
And I don't know the math. I just maybe Wayne knows the math.
I know.
That would make sense. The same thing as, you can take longer exposures aiming towards the pole versus at the celestial equator.
Yeah, and
Sure.
actually, if you were sitting on the equator and you pointed your Alt-Az mount directly at due north then it's kind of an equatorial mount. So that will
Right.
help.
Sure.
So you'll be when you're down south there in the Caribbean, you'll be better. You'll have less of
18 north. Yeah, thank you.
try to point it north.
There you go. So this slide actually shows pictures I took with the EV scope of the M81 galaxy Bodies using the Seestar at different exposure intervals, right? To give you a sense kind of how the image evolves as it has more time to stack more frames. At 1 minute, it's distinctly unimpressive. It probably doesn't look much different than Bodies would look through a purely optical telescope. It kind of looks like a small gray blob, right? But then at 12 minutes, you're starting to see some of the sort of arms of the galaxy. At 33, it's becoming clear. At an hour and a half, 102 minutes, you can actually see pretty clearly, the distinct spiral arms of Bodhi. And then with some really fairly basic processing in Lightroom and some cropping, you can see the final image is definitely identifiable as M81. So, in some ways, it's kind of like the slow motion version of Polaroid films. For those of you, I know I'm already dating myself, I apologize, but where you sort of see it develop over time. And honestly, that is part of the magic for a lot of people. When they see the images develop in these types of telescope where the plate stacking is taking place in real time, that's tremendously impressive to people. It's like, oh, it's getting clear, right? That is definitely part of what this is about.
Grace?
Yeah.
So the times up there, the 33 minutes.
Yeah.
That is the sum total.
Yes.
Of all the frames which go into making that.
Exactly.
Stacked frames. And
Right.
so what I'm wondering is, for each individual frame, how long would that exposure?
Great question. With the Seestar, you have three choices. The individual frames can be 10 seconds, 20 seconds, or 30 seconds.
I see. Okay.
Each of them has their pros and cons. At 30 seconds, you start to run into some risk of star trails, depending on what you're looking at and the altitude of the object in the sky, but you're collecting more light. 10 seconds, that's not a problem, but you can kind of make dynamic decisions that make sense. So for example, if you're taking 10-second exposures, that means you're taking 6 frames a minute. And a 12-minute exposure, we're looking at essentially potentially up to 72 frames. Now I say up to because what the telescope does, as I said, is it will discard frames that it's having problems. It can't properly register or align them, or the plane line pass, or what have you. So to get 12 minutes of sort of stacked images may take longer than 12 minutes, depending on how many frames the telescope is discarding. But that's a ballpark. So 102 minutes, that's over 600 frames. Right, that's a lot of frames.
And which format do you use to record these in?
You have choices with the EV scope. You can use JPEG.
With this.
Sorry, I'm sorry, with the Seestar, excuse me, that's what I meant to say. With the Seestar, you can choose to save the images in JPEG, TIFF, or in FITS. And I'm going to show you an example later on of some images processed in FITS by another HAL member. But this kind of explains the idea. Go ahead.
I think it would be really cool to repeat this experiment in Portal 5, Scott, at the observatory, and
Sure.
maybe even under real dark skies. I'd be very curious to see how quickly the image really pops out.
Well, I can tell you from my experience with the EV scope, since I've imaged at home in Baltimore, around Baltimore, and I have taken it out to dark sky places. The net difference is the images develop much more quickly. You tend to have a lot less issues with background noise and light pollution in the image, so you tend to get more clarity as well. So these telescopes are remarkable in the extent to which they can succeed in high light pollution environments, but less light pollution helps. Absolutely. That never goes away.
Grace, there's a question in the chat. Atul asks, it appears that the image changed orientation from 33 to 102 minutes. Did Seestar do that, or is that your post-processing?
That's an article that was me. This is from 2 different imaging sessions. So the 3 images were from one session, the last 2 were from another session, but they were both from the same location, my patio. So and there's roughly the same observing conditions, but they were just from 2 different observing sessions.
The final image is magnified about 2 times.
Absolutely, I've cropped it and I've processed it in Lightroom, and I'll talk a little bit more about that later. So I want to be clear that the final image is not what you see natively in the telescope. The one you see native in the telescope is the one just before that, right? That's what it actually looks like directly. And then I chose to crop and process the image. And I'll show you some more examples of that later on. So, people can clearly see the delineation between the raw image from the telescope versus what's possible with post-processing.
Atul, you get a prize too.
Yeah, absolutely. Good catch. Okay, so you can kind of think of smart telescopes in 2 generations. The first ones came out roughly around 2018 or 2019. The EV scope, for example, was funded as a Kickstarter project. I'm not sure about Ionis or not, but essentially they were the first 2 entrants in this marketplace. You see examples of their telescopes over here on the right. And they already started to revolutionize this market. They are easy to use and set up, especially for newcomers, simple operations, and high quality images of DSOs. That said, there are still some challenges for some people, depending on what they're looking for in this. They're relatively expensive. The least expensive unistellar or Ionis telescopes I've seen are about $1,500, and they typically go up to about $4,000, depending on the model you get. At least the EV scope is too big to take on a plane and carry on luggage. It comes with a backpack and it's great, but there are some constraints there. And this is not true of the Ionis, but with the EV scope, because it's a reflector rather than a refractor telescope, it involves some manual focusing using a bat knob mask, and you had to collimate it occasionally. So it was dramatically easier than traditional setups, but there was still, or is still, some labor involved. And for some people, that's not an impediment at all, but for some people, that's a consideration. So then the Seestar and another telescope that emerged last year called the Dwarf 2 are kind of what I would call the second generation of telescopes. I'm not going to spend a lot of time on the Dwarf 2. We looked at that as an option for purchase by HAL. It has a much smaller focal length and is targeted as much to landscape or terrestrial photography as stellar photography. But there are people who have acquired it. Jared from HAL has acquired one, and there may be others. So it's another option to look at. So what are the differences between sort of these Gen 2 telescopes and the prior generation? Well, they're cheaper, a lot cheaper. The Seestar is $499, which is a pretty dramatic difference. They're smaller and lighter. So here's the Seestar over here. The dwarf, I think, weighs about 2 pounds. The Seestar all in with the tripod and everything else is about 6 pounds. It has a variety of imaging modes like solar and lunar and so on. But it also has shorter focal lengths. For example, an EV scope has a 450 millimeter focal length. The Seestar has a 250 millimeter focal length, and the Dwarf 2, I think it's 100 millimeters or something like that. So,
So is the Seestar, I assume it's a 50 millimeter objective?
it's a 50 millimeter objective, yes.
Okay, so it's f5.
Yeah, in fact, the next slide is specs.
Ah.
So here it is. So it's an APO triplet refractor. So it's not a doublet, it's a triplet.
Okay.
50 millimeter aperture, 250 millimeter focal length, therefore f5. 1.3 degree field of view, so you can see the full moon in there, and a number of other objects. All of Orion, et cetera, et cetera. The sensor is about 2 megabytes, so it's 2K by 1K or 9. Essentially it's Blu-ray resolution, 1920 or HD resolution on your camera. It's exactly the same. And it uses a Sony sensor. Sony has a line of sensors called Starvis that, interestingly, are often used for things like security cameras and dash cam cameras because they're more sensitive to infrared light and therefore are better suited for night sky photography. But sometimes they're not super high res. I mentioned previously, you can save the images in a number of formats, and you can choose to save the individual subframes as well as the final stack frame if you choose to. And you can also do video on it in both MP4 and AVI formats. There's 64 gigabytes of storage built in, and of course you can download those images to your devices. You connect using Wi-Fi and Bluetooth. It comes with a case here. See here, it comes with a mini tripod, not a full-size tripod. It basically is one designed to be mounted on tables, and a solar filter. And it has a built-in light pollution filter. Battery life is give or take 5 or 6 hours. Depends on whether you have the dew heater turned on and how often you're slewing, et cetera, et cetera. But that's in the ballpark. But you can recharge it while it's in operation. So if you have like a USB sort of battery pack, and we got one for the Seestar, you can run this thing all night.
Wow.
Yeah, absolutely.
The built-in dew heater. The
It
built-in
does.
dew heater. That
Yeah.
Beautiful.
Yeah, weighs about 5.5 pounds, and they said the price is $499. Okay, so
There are a couple other questions in the chat.
okay, yeah, I'm not watching chat here. I have it full
Yeah,
screen, so please just
yeah.
throw the questions at me.
So Arjun says, how faint of an object can the telescope image?
I don't know what the technical specs are on that. There might be some stuff on that. I haven't seen anything where it says there's a specific limiting magnitude. Some of the other smart telescopes have it. I haven't seen that. But, in practice, it's, a fairly short focal length and a fairly compact sensor. So, there are some constraints there.
Okay. And then the other question, which actually David Stein answered, there was a question, can you do star trail images? And David Stein says you could put it into scenery mode and then do it that way.
Sure.
Yeah.
I hadn't thought of that, but yeah, you could.
All right. Sorry.
No, thank you. I'm glad somebody's monitoring chat because I'm just looking at this full screen.
I think people have questions that are kind of like that.
Go ahead.
This is perfect for what we call fixed stars that are rotating with, the Earth's rotation. For tracking other things like the sun and moon, it's got that built in, right?
It does.
Track that. Planets probably not so much, but if you're
It does have planetary tracking.
okay.
Yeah.
But what about an asteroid comes along and it's discovered that it's going to come close to the Earth and it's going to go kind of fast across the sky? How do you deal with a thing like that?
Oh, that's a good question. Well, you have a few options. In that case, you could basically, for example, use the scenery mode, which basically just sort of takes individual images and you can save them. You could, or actually planetary mode kind of does something similar, right? Even if you're not looking at a planet. So there are probably ways in which you could do that. And the catalog for it does have some options like some comments and so on built in.
Yeah,
Can't do those.
they're another thing.
Yeah.
I guess is your question, is there a way to add a custom object to the
Yeah, yeah.
database, so you could?
Yeah, because what if you had
orbital
prediction in advance and you knew
You can put the
coordinates, you
coordinates in-
knew,
You put the coordinates.
In the app, you can put the coordinates
and you
in.
knew the motion that it was going.
Well, if you're, now you're
undergo.
talking about
And
a
you're stuck.
$500 intelligent telescope, so it doesn't have all of that.
Yeah, okay.
The one thing I need to caution when people are talking about using the scenery mode
Yeah.
is the scenery mode is fine if you want to get star trails and you can point up and you visually know where you're at.
Right.
Because what happens is when you go into scenery mode, all of your night vision, all your astronomy stuff goes away. You don't have any astronomy
Okay,
control
yeah,
because you're in the scenery mode. I've used it
okay.
in the scenery mode, and it's
Right.
just like using any other
So
daytime
it no
camera.
longer knows what it's looking
And
at.
no,
Right.
it's not looking for anything because it's in scenery mode.
It's basically just a dumb 250 millimeter fixed focal length camera. I don't mean dumb in a bad sense, but you know what I mean.
Right.
You manually move the.
Right.
on
Yeah,
the app, you
There's
manually-
basically an on-screen joystick you can use to point this thing around.
Okay.
Okay, so just some overviews of the actual mobile app that you use to control the device. If any of you have ever seen the ASI Air application for ZDO, you can see that there's some family resemblance there. In particular, sort of the Sky Atlas feature seems fairly similar, and some aspects of the interface don't seem that dissimilar. But of course, it's dramatically cut down in functionality and simplified compared to something like ASI Air. You can select and visualize potential targets a number of ways. You can simply type in what you want to look at and they'll salute it at. But if you want to see a picture of the night sky and then zoom in and zoom out and look at objects and sort of roam around the night sky and then identify your targets that way, just like you would say stellarium, for example, you can do that too. The built-in object, the sort of telescope / app has an object catalog that includes Messier, Caldwell. I don't know if it contains all of NGC-IC. It seems to contain a significant portion of it. Definitely bigger than what I could tell the Unistel and the Veonis support. It seems like a bigger catalog. Planets and other bodies like comets. It's available for iOS and Android. It's free to download. And to ZW's credit, they are making a lot of enhancements to the app and the firmware on a pretty regular basis. You know, just since we purchased the telescope in December and now they've added a planetary observing mode that didn't exist when we bought the telescope, just to give one example. So hopefully that's an encouraging
Yeah,
sign.
it's pretty nice to have a device that can be more capable than when you bought it.
Absolutely, you know, and there's all kinds of potential upside there.
With the 250 millimeter focal length is what on planetary imaging.
I will show you an example of a planetary image with it. You have to calibrate your expectations accordingly.
Yeah.
With a 250 millimeter focal length. It's better than it was when the telescope first shipped. I'll show an example of an image, but it is not, most optical telescopes will give you a superior view of Jupiter or Saturn than the Seestar will. That's just a function of its geometry, if nothing else. But they have made it better. I'll show you a slide on that later on. So this is a screenshot of the homepage of the application, where you can sort of see information about the status of the telescope, current viewing conditions, where you are, which is kind of handy. There are 5 modes: stargazing, solar, lunar, planetary, and scenery, and I'll walk through all those briefly. It has kind of a sort of a concierge menu of targets you might want to look at tonight based on your location and observing conditions, called Tonight's Best. And then at the bottom, there's a tab with a variety of options: the Sky Atlas or Stellarium view. You can see who else. There's basically the equivalent of a social media feed where you can see photos from Seestars that other users have posted. And you can even narrow it down to posts specific to your region, what they call nearby. So if you want to see who else in Baltimore has a Seestar in the images they posted, you can do that. And there's some account settings as well. I won't go through every aspect of the app in detail, just in the interest of time here, but I want to give you sort of the flavor of how it works. So the first mode, the one that people will probably focus on the most, is stargazing, which is essentially synonymous with deep sky object, whatever else you might want to call it. As I said, there's many ways you can find an object. You can use sort of the Tonight's Best menu. You can use a stellarium like Atlas. You can search, using a search dialog. You can browse by type, like for example, nebulae or galaxies or so on. One thing I really like about its sort of browse feature is that it organizes the objects by altitude. So the objects that are highest in the night sky come sooner. So for those of us who sometimes have constraints on what they can see from where they're viewing, that's really handy. Like I know if it's 10 degrees above the horizon, I'm not gonna do the imaging, right? But this makes it easy to do. And then once you selected your object, the Seestar automatically slews to the object, centers it, and tracks. And when it's centering, you'll see that sort of picture on the upper right there. You'll see sort of red and blue rectangles. And essentially, when they're on top of each other, the Seestar has sort of centered the object against, the designated target. Which is kind of neat. It's a sort of neat visual way to see the telescope. And the telescope, I didn't mention this, also speaks, has a voice. So when the telescope is centered on the object, you'll hear the telescope say, object centered. When it turns on, it says, telescope ready to connect, and so on. Of course, you can turn it off if you don't want to hear it, but there are times that it's actually kind of handy to have that sort of audio clue. So that's kind of
I
neat.
have to tell you, when you turn it on the loudest volume, I had it on my deck, I was in my kitchen with the door closed, and I could hear it telling me that it was ready to go.
There you go.
It was like, take the trash out. I could hear it.
You want to know, one of the biggest single value propositions of the Seestar, especially this time of the year, like last night I had this thing out, it's like 15 degrees out, right? I plunked the telescope on a table in my patio, right, connected to it, went inside where it was nice and warm and toasty. I could go almost anywhere in the house and I could control the telescope, right? I didn't have to be out there freezing my cans off. The telescope was doing it.
And you were running off your home network then, right?
Yeah, absolutely. So, so that's pretty handy. So then, once you've centered on the object, then the app enters sort of imaging mode. And so this is sort of the screen you see. This is just, a simple object I'm looking at here, but I've sort of annotated sort of the things you can do in the screen. The only dynamic control you can set while you're actually in the process of imaging is brightness, which I think just affects basically how the image appears to you. It's not changing anything intrinsic on the telescope. It's just adjusting the brightness level in your app for it. You can choose whether or not you want to activate the low pass filter, and it really does make a difference for imaging. You can push a button called mark to identify objects the telescope has basically placed all four on screen, and there is an autofocus button. I typically use it at least once or twice a night. I don't autofocus the telescope every object I go to if I'm going to 10 or 15 objects a night. I just don't find it's not that necessary. But I do it at least sometimes, and sometimes it makes a difference. You can manually do it as well. You can purchase a Vatanov mask as a third-party accessory if that's what you're into. And then down at the bottom, you'll see that little sort of red square with a circle around it. So as the telescope is imaging, for example, if you're doing 10-second frames, you'll see it count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then it'll restart, which means it's just completed taking a frame. And then on the upper right there, it's not easy to see where it says stacked imaging time. It'll then increment the imaging time. If it took a successful frame, it'll go, for example, from 40 seconds to 50 seconds, and then 60 seconds, and so on, as you go forward. So it's pretty easy to understand it as you're imaging.
At what point does it figure out which frame, that a frame was no good because it has a streak in it?
Pretty much.
Take that out of the display.
Pretty much immediately, and you'll actually see a brief message on screen saying frame dropped or something like that. Okay. You don't have to do anything. The telescope will just notify you. And there certainly have been times where I've been able to correspond the message to, oh, look, there's, a plane going across or something else. Other times it could be vibration or something else, depends. But generally it's pretty good about that. I have found in my experience, it's generally not dropping more than about 10% of frames or so. But of course that depends on your observing conditions and other things. But it does a pretty good job of holding on from what I can tell. Okay, and then when you hit the red button, it saves the image to your photo library, just on your phone, or your iPad, or what have you, and then you can process it and share it the way you would any other photograph. And you can continue to take progressive images as I did before. So you can take an image at a minute, right, and then the imaging stops while it saves it to your photo library. And then if you hit the button again, it'll say, do you want to continue at a minute, or do you want to restart the whole sequence again? But you can take a sequence of images if you want to as a progressively stacked.
So the image that you see there, is that the cumulative?
You're seeing the cumulative stack
build up over time.
Absolutely.
Okay.
Is there a way to tell it to save each of the individual frames?
There is. I don't have it here, but there's a separate preference setting where you can say save individual subframes. Absolutely. And so for those of you who don't want the telescope to do the stacking for you, but you want to stack it yourself using Deep Sky Stacker or Fix Insight or some other piece of software, absolutely. The only difference there is the way you retrieve the subframes, right? The sort of stacked images you simply download to your app, right? That's like wirelessly. For the individual subframes, you can't do that. There's two ways to do that. You can connect to the telescope like your laptop with the USB cable, or it also appears as a network share, like as a network drive, and you can download all the individual subframes that way. But yeah, you can absolutely download the individual sort of unprocessed subframes and stack them yourself if you want to. Okay. So moving on, I want to be conscious of time here, so I'll try and go through this as quick as I can. Here is solar mode. So it does, I think, a pretty good job. Essentially, the deal is this: set it up, point it in the general vicinity of the sun. It doesn't have to be exactly the sun, but in the ballpark. And then you can sort of tell the Seestar to go locate the sun, and it'll start tracking the image. This is
solar filter.
Yes, I should be clear with that. For those of you who are interested, the telescope comes with a solar filter that you put in front of the lens.
Before.
And the app reminds you to do that.
Okay.
Because you could damage the camera sensor if you didn't do that. But it's important to know that it's a white light filter. It's not an H-alpha filter. So essentially that means you can see sunspots, as you see. This is with an actual image, but you can't see things like prominences unless you're in an eclipse or something like that.
Yeah.
But still, that's pretty impressive, And you can also do, and this is true of lunar mode as well, time lapse and video mode. So you can see the sunspots rotate across the sun in time lapse mode if you want to, and it has video mode as well. So that itself is
Right. And by the way, you see the sun's not fully captured in there. We learned recently that if you squeeze the image down, you could get the full sun in when you're recording in JPEG. But when you're in video mode, it automatically fits it in.
Okay, good to know.
Yeah.
Here's an example of lunar mode. Not a lot to say about this. You can ask the telescope to locate and track the moon, or if you choose to, you can manually salute the moon, whatever you prefer. There's, the moon, the whole moon can't fit in the frame. And my personal 2 cents on this is the detail level of the lunar photos is pretty impressive. It's as good as what you would see with a lot of, for example, SLR type camera gear with an equivalent lens or things like that. And again, if you want to see clouds moving across the moon or whatever, you can put it in video mode.
And one thing, like for those of you who may have it or you're getting it when you're in solar mode, if it starts to drift out, there's a soft button on there for tracking, because if you don't, you'll see it'll start to drift, and so it can drift right off your frame. So you lock that in, and it doesn't move.
Yep. Thank you for explaining that. Planetary mode. This gets back to the question people were asking earlier. So basically, it's easy to find planets in the planetary mode. It comes with a list of the planets, and it shows you their current altitude and everything else. Pick them, and then it salutes the object just as it would a deep sky object. The image in the bottom left is what Jupiter looks like, so all by itself in the picture. It's a small white dot, but it's a 250 millimeter focal length. That's what you're going to get, right, with a relatively small sensor. What you see on the right is that dot basically blown up or enlarged and dropped, right? Is it better than just a white blob? Sure. Is it as good as your average optical telescope? Not so much, but it's something. So different people will have different views on the utility of this mode, but it is available, right?
You see the bands there.
Yeah, I mean, there's something, right?
Some features.
So
Right.
if you jack up the brightness, will the moons of Jupiter show up? Have you tried that?
Yeah, you actually can see the moons. They look like tiny white dots, but yeah, you can see them. Yeah,
cool.
like the Galilean moons. Right?
Yeah.
So then the last mode is scenery mode, which is basically now your telescope is becoming a fixed 250 millimeter focal length camera, like a DSLR type camera. There's no manual settings for things like aperture, ISO, or exposure time, things like that. All of that's managed by Seestar, but it does a pretty good job.
Yeah.
Well, there you go. Phil is showing an example of a flag picture.
Yeah, it really shows the detail.
Right.
And this was shot off my deck across at the neighbors with their windows closed. And
Right. And again, you can also shoot in video mode if you want. And so basically a virtual joystick appears on screen and you're simply manually pointing to the telescope at whatever object you want to look at. There's no tracking. Okay, so those are the modes. So I want to talk a second about post-processing. So that's been raised. You can directly download the finished stacked images in JPEG or TIFF. The FITS frames can be downloadable. You can download the stacked FITS image as well as the FITS subframes. And so you really have three options. There's nothing, which is basically the raw images, which, hey, sometimes maybe that's what you want. You've got a decent shot of Orion. You want to post it on Facebook right then and there, right in a camera library, go to town, right? Then you can decide if you want to do further processing. You know, I'll call them basic and mid-level tools. So I use Lightroom as an example, or GIMP for other tools like that, right? To do where you can really make a significant difference. I'll show you an example of that. And the last are what I call pro tools, like Zero or PixInsight or Photoshop, where you can really get in there and do detailed image processing with specialized tools. But of course, that requires greater expertise and more time and so on. So rather than talk about that, I'll show you some examples. Here are three different objects shown with both the raw image, a version of that picture that's been processed in Lightroom by me for those three objects. And then the final one is the stacked FITS frame that's been processed by a different HAL member, Steve Rifkin. So Steve has posted these pictures on social media, and he kindly gave me permission to include them in here so you can see by way of comparison, at least what's possible, you know, if you're adept with some of these more sophisticated tools in terms of the quality of image processing.
Amazing.
Does that help in terms of giving you a sense of what it's capable of?
It's amazing.
Yeah, you know, you really can see some pretty high quality images there if you're willing to put in the time and use the tools. Here's a few more pictures of images that I took, and I did basic Lightroom processing. When I say basic, I mean, just in controls like contrast and brightness and you know, highlights and shadows and saturation and a few other things. But I'm not trying to change the white balance or do any, you know, I'm not using third-party tools for sharpening or noise reduction or anything like that. So this is basically about 5 minutes of processing an image, give or take.
And were these all from light pollution?
Yeah, these were all taken from my patio. Yeah. So there's Eastern Vale. I put M52 to see an example, so you can see an example of what a cluster looks like. Cygnus Wall, which, as many of you may know, is one of the North American nebula, and then the Lizard Nebula. And of course, everybody will process images differently. This is sort of my preferred aesthetic, but you know, it's in the ballpark of what I think you would see. Only a couple. There's some accessories available for it via eBay. There's a filter adapter, so you could use off-the-shelf 2-inch filters,
which we have.
Yeah, and the lens cap, which we purchased. You can also get a Bahtinov mask. You may find it helpful to get a full-size tripod. This thing just mounts on any standard camera tripod, a tripod balancer to make sure the telescope stays balanced, and a battery pack, which I talked about. So what's it good for? Well, learn about the night sky, right? It's great for social astronomy. You know, fire up your iPad and pass it around at your party. And you know, everybody's sort of looking at it, right? You don't have to line up to look through an eyepiece. It's great for like message type marathons. You can just punch object after object, or for public star parties, you can image 10 or 20 things in a night if you want to, easily. It's grab and go. It's so small, you can take it anywhere, take it on a plane, put it in your car or whatever, and you're up and running in 5 minutes tops. I've already talked to some HAL members to say, you know what, I'm getting this a second telescope. I'm still going to be imaging, or I'm still going to be observing like through my, you know, optical telescope, but I'm also going to use this and image at the same time, right? And so what are its strengths and its limitations? Well, you can't beat the price. For what it does for $500, that's, in my opinion, that's pretty jaw-dropping. That's a pretty astonishing development. It has multiple observing modes. It requires absolutely no knowledge of astronomy to start using and getting great pictures. That's a huge proposition right there. Incredible focus on ease of use. You know, you can learn how to use this thing in less than 5 minutes, and you can set it up in less than 5 minutes. It works, you know, as you saw from my images from my Bortle 8 location, pretty well at filtering out light pollution, and the wow factor for DSOs especially is good. It has some limitations. I initially thought you could connect multiple devices, like multiple devices to this at the same time. Based on more research, ZW is saying, in fact, you can't. It's one device at a time. Who knows, maybe there'll be a firmware upgrade in the future, but it's one device at a time. We've already talked about planetary imaging quality. In part, that's a function of the fact that, you know, it's a limited focal length and sensor limit. So if you're looking at a really small planetary nebula somewhere that's, you know, not very wide across, with the small stand from 250 millifocal length, there are some limits. Some competitors like Unistellar have things like citizen science programs where you can, try and observe occultations and exoplanets and stuff like that. ZWO at the moment at least isn't there. The closest thing they have is basically a picture feed. And it's early days. I will say, I know some users, and if you follow the Facebook channel, who have been struggling. There have been people who have had issues with tracking or things like that. We haven't had any problems with ours. But I know of one HAL member who has definitely experienced challenges. This is a brand new product. So, that's something to keep in mind when you're making decisions. So how are we planning to use it in a HAL? Well, at Public Star Parties and Outreach, we're really looking to use it as a tool to sort of help sort of share the night sky with people. That's part of why we got the iPad, so somebody can sort of demonstrate and show them the pictures as we go along, and people can really engage with it. That's kind of what I've done with the EV scope today, but now this is something anybody at HAL could do. We're also working on a program, we still have to work at the details, where if you come to an impromptu or a member star party, you can sort of check it out for the evening there at Alpha Ridge and use it to do imaging yourself. Explore the telescope, decide you want to buy one and play with it, do whatever you want. We purchased the iPad to do that. I think one of the things I'll say that I think we'd like to see is, as people become fluent with the HAL Seestar, is we can be ambassadors out to the community and maybe to some underserved communities who don't have a lot of access to astronomy out there. This could be a valuable tool for us to open some new doors. I'll leave it at that.
Yeah, so just, sorry, one more word on the HAL usage of the Seestar. I think the board has agreed that we don't know exactly how, but we want to allow members, it's not such a large investment that we're, I mean, we obviously want to have it taken care of, and we want to be careful with this thing, but we're comfortable letting users check it out. We don't have a process for checking it out for extended periods of time. So we thought we'd start with just, let's see how it works. If there's a members only star party, whoever calls a star party, somebody says, I want to use the Seestar, we're not entirely sure how it's going to work out if, 2 or 3 different people say they want to use it on any given night, but we'll just see how it works out and how it plays out. But, hopefully we'll all be reasonable. Maybe first come, first serve, we'll see. But if somebody calls an impromptu or a members only, or when on the members only, you can in advance request it. And if somebody calls an impromptu, you can request it as well. So we'll have to work out the details of who approves or who assigns it. But I would love to see people just using this thing, and more the merrier, because then maybe you can use it at a public star party and share views.
Grace, I want to set up note for everybody. So the one thing, everything Grace said is 100% accurate. There is one setup thing that's important, and that's the leveling. And it has to be level. And if it's not level, it will tell you it's not level, and it comes up with a little display to help you level it. But that's the one thing, make sure it's level. So if you pick it up and you adjust it, you move it, you might have to re-level it, because that's how it knows where it's at. That's the only thing. And it's simple.
Yeah, and HAL has purchased it's at the observatory. We've purchased a full-size tripod for it with a leveler. So there's a leveler attached to it that'll make that easy, hopefully.
Yeah, that serves the same purpose for Altazimuth mount that setting up with or alignment for a tutorial.
I want to be conscious of time. I know we have other material covered. This is the last slide. Just, I see this as part of a new wave of tools for astronomy, and it's encouraging that HAL is, investing in that and, taking advantage of some of the opportunities that are going to present itself by virtue of that. That was it.
Thank you very much. Do we have questions?
Yeah, I have a great, when Phil said, I assume you have it hooked up to your home network, but you don't, this can be taken out in the field. Do you need an iPad with, is everything internal, or do you need Wi-Fi or a?
No, good question. The telescope is itself a Wi-Fi hotspot. So you don't need access to some additional network to use the telescope. you connect directly to the Seestar as if it was any other Wi-Fi hotspot.
And the reason I asked Joel is because when Grace said she was moving around all over her house, the Wi-Fi, when it's out on the deck, you're gonna lose that if you get too far away, but when you connect it, if you're at home and you connect it into your home network, you could go anywhere.
Yeah.
Yeah, because it's as powerful as your home network.
Yeah. But yeah, when it's 15 degrees outside, you are thanking your lucky stars that Wi-Fi telescopes exist. I'll tell you that.
So, in the interest of, are there any other questions? I think we should move on in the interest of time, but I will say that in the chat, there have been a number of questions I'm just noticing now, and thank you very much to David Stein, who's been answering them. The chat is recorded and will be posted, on the website too. So if you want to look at the chat now, if you're online, or look at it later, you should do that. And then one other thing I'd like to do is thank Jared Case, because he early on with his dwarf, he shared some of his dwarf experiences and helped to get some of us in the club excited about these. So thanks to Jared too for getting us involved. So any other last questions for Grace before we move on?
Thanks to Grace, right?
Yeah, thank you so much.
Thank you.
All right.
Not gonna wait for another. Thank you.
Well, this could be the first of just a whole line of improved.
Yeah, this
versions.
is,
If I'm thinking, can you get some folded optics that give you a longer
Yeah.
effective focal length?
So, did everybody see the meeting PowerPoint?
Yes.
Okay. All right, well, let's move on. Next up, we've got Jim. Are you on?
Yes, I am.
So please go ahead.
Alrighty, so the shallow sky for the next period, next meeting, we're in a we're going to get into a drought here probably as the spring unfolds, but for right now, Mercury and Mars, they're kind of poor targets. They're early morning items. The one thing of interest is the 27th of this month. If you can get a good eastern horizon and a pair of binoculars, you can see them have a very close conjunction, only a quarter of a degree apart. So that would be kind of interesting, but that's really pretty much the only highlight for these two. Venus is, we had our inferior conjunction where it was at its largest back in August. So it's continuing to head towards, I think, a June superior conjunction. And so it's continuing to fall back towards the solar glare and shrink in size. So again, not a particularly enticing object. Next.
No,
So Jupiter is going to be the star of the show for the next couple months. It reaches what we call Eastern quadrature in a couple of weeks. When a planet reaches that point, basically at its best as soon as as soon as it gets dark. So if you're going to look at Jupiter, the best thing to do is to try to catch it as soon as twilight lets you see where it is. Saturn had its opposition back in August, so it's getting lower and lower. And also it's the sort of thing where if you're going to take a peek at it, do it as soon as it emerges from the twilight. You've got only a few more weeks of Saturn at the most. Next. We do have one of these Pan-STARRS comets out there. It's magnitude 7.5, which isn't too bad. If you have binoculars in the dark sky, you could probably pick it up. It starts off February very close to Antares, so it should be fairly easy to find. And then it starts swinging northeast into Ophiuchus. And in the middle of February, there's a really nice imaging opportunity. Maybe you could use your Seestar, I don't know. But it goes right by globular M9, which is a fairly decent globular cluster. And then a couple of days later, it even gets closer to another smaller one called NGC 6356. So that could be kind of interesting, but again, that's an early morning object for you to get up and look at. Next. So I thought we'd talk just a few moments about, since Jupiter is the main star of the show right now, some fun that you can have with Jupiter. About a week and a half ago, I went out and got this particular image. Horrible seeing conditions. It was like a 2 out of 10, but it was still neat in that all 3 moons were visible and were undergoing some activity. So the Io was about ready to slip behind the planet there. You can see that on the right. Europa had already started moving across the planet, and Ganymede was queued up, and about 15 minutes later was going to run across the planet with its transit. So if you kind of take that image and you put it in WinJupos and you can get some grid lines, what's kind of neat, you can see here, you can imagine that the plane for the moons is kind of tilted towards you. So in other words, you can see that the 2 moons about to cross in front are below in the southern hemisphere. The moon about to scoot behind is in the northern hemisphere, the way that we're looking at it. So you can kind of envision in your mind's eye that the plane, the ring plane for the moons is kind of tilted towards us. And if you do that and you look at something like this, you can also then kind of get a rough feeling for which moon orbits at what distance. So closer to the equator, it's tighter into Jupiter. So Io is at 422,000 miles. Europa, you can see here, it's about almost twice in terms of looking at the grid. Not quite twice when we look at it, 671. Same thing with Ganymede. It's further down in the southern hemisphere, so it's even further out. And if we had Callisto, you'd see that Callisto misses the planet entirely because it's so far distant that it's not able to cut across the planet at this time. As Jupiter tilts and those the ring plane kind of comes closer to the equator, Callisto will again begin to have transits. Next.
Hey, Jim, does that like similar to Saturn, where there's the plane of the rings kind of wobbles over that 17-year cycle or whatever? Does this also wobble on some?
Yes. Yeah, over the 12-year period for Jupiter, but it is only 3 degrees as opposed to Saturn's 24 degrees. So it's much less.
Okay. Interesting.
So next slide. And I just thought I'd throw it out here. If you get your scope out on the night of the 29th, you've got kind of an interesting thing where Io will emerge from eclipse. So it'll move out of Jupiter's shadow. And then Europa will come out from behind the planet, be visible for a little while, and then it will slip into Jupiter's shadow. So kind of mark your calendars if you want for the 29th from about 9:20 to 10:20. The moons will be putting on an interesting show for you. And that's pretty much what I've got for this month's Shallow Skies.
Awesome. Thanks. Any questions? Okay, we'll move on to Wayne.
Okay, next slide. Okay, so for this month's What's Up in Space, go back a slide, please. No, I'm sorry, you're right, Sorry, I apologize. So I want to talk about a JWST press release on the cat's tail in the Beta Pictoris dust disk. So it was observed with the James Webb Space Telescope's near infrared camera and the mid-infrared instrument, the MIRI. So just to give you a quick reminder of what Beta Pictoris is like, it's a very bright star. It's a spectral type A6 main sequence star with a visual magnitude of 3.81. So it's easily visible with the naked eye. And here we are observing it with a 6.5 meter telescope. And it's at a distance of about 63 light years from the sun. Beta Pictoris was the first edge-on debris disk that was ever observed, and that was reported back in 1984. So we've known about this disk for a long time, and we're just they're observing it to get more information about it with the infrared telescope. The disk consists of two disks. There's a main disk that is horizontal in these images that you can see here that I'll get to in a minute. And then there's a tilted secondary disk. And Beta Victoris also contains at least 2 exoplanets, each of which has about 10 masses of Jupiter. So they're big exoplanets. So if you look at the pictures on the right, they're actually the same image, just duplicated, and the lower one is annotated so you can see the parts that it's looking at. So the big black circle in the center with a star symbol in the middle of it, that's the occulting disk. Because the star is so bright, they have to do what they call coronography in order to observe the object, and they basically block the light of the star itself from reaching the detector, and that allows them to see the faint structures around the star. So yeah, the bar is just there as part of the occulting disk. I'm not sure if it's a physical, if it's physically holding the disk or if it's just some other aspect of the coronographic mask. Okay, so going across horizontally, you can see the brightening that's the main disk. It's very nearly edge on to our line of sight. And then extending mostly off to the lower left from the main disk, but pretty close to it, you have what they call the extended secondary disk. It actually extends yes, thank you. It actually extends over to the right of the star, also above the main disk, where it then transitions into what they are now calling the cat's tail, and for obvious reasons. And then there's some additional nebulous material, dusty nebulous material up above the cat's tail. So this is what they're observing. These are MIRI images, by the way, I should have said that. So we're looking in the mid-infrared. That's a combination of 15.5 micron and 23 micron light. So this was images were taken as part of a study of the dust disk. It was JWST proposal 1411 from Chris Stark, and it uses obviously NIRCam, MIRI, and coronography in order to make the observations. Specific paper was the JWST-TST. TST stands for the Telescope Science Team, and it's a high contrast work, and they're reporting on asymmetries, dust populations, and hints of a collision in the Beta Victoris disk with NIRCam and MIRI. And it's the papers by Rebelito and others, and there's the archive reference to it and a link to it if you're interested in looking at it in more detail. It's a rather long paper, so if you're going to read it, be prepared. Okay, next slide.
So the cartoon of the blocking coronagraph thing, whoever made that should have used the 6-pointed star, I think. Sorry.
Okay, so the principle, can you hear me? Somehow it sounds different.
We hear you.
Okay. The principal results of the study are twofold. First, there's observational morphology information. And the second, they did some modeling to try to explain the morphology. So first of the thing they've determined is that the secondary disk is inclined about 5.5 degrees to the main disk, and it's got an asymmetric distribution of material. There's more disk material on what we see as the left-hand side of the secondary disk, the one below the main disk, than there is on the right-hand side. Okay, so the northeast part of the secondary disk has more material in it and extends farther out than in the northwest part. The curved filament that we've already talked about is what they're calling the cat's tail, and it's part of the disk, and it appears to be inclined at a high angle, about 45 degrees actually. I do want to emphasize the word appears. The secondary disk and the cat's tail are only visible in the MIRI images, and that strongly suggests that we're seeing them by thermal emission from the dust particles as opposed to scattering the bright starlight. The main disk is primarily a scattered light feature. Furthermore, because we're seeing the thermal disk from the cat's tail and the secondary disk and a lot less from the main disk, that suggests that the cat's tail and the secondary disk are hotter than the main disk. And that then suggests that they're probably consists of porous organic refractory grains. That is basically dark organic material that's glowing in the infrared. Okay, so those are the main more observational results that I'm going to mention here. There were others in the paper. I'm kind of didn't have time to get to all of them. And the relevant modeling of this disk and these features, they used what they called a point collision model, which basically, if you look at the image on the lower right, they basically, in fact, look at the right-hand side of that. It's a little hard to see maybe, but they basically assume that the disk, the secondary disk, is material orbiting, but it's orbiting with a rather high eccentricities. And basically you have collisions occurring sporadically there on the very right-hand side where the little arc comes off of the disk. Okay, can you see? So basically they're assuming all the collisions happen right there because the material is getting concentrated there. So that's the most likely place to have the collisions because that's a more dense region in the disk. Okay, the model includes radiation pressure, which will tend to push the particles away from the star, and interstellar medium drag, which will tend to drag particles away from the disk, which is how you get the cattail basically. And so they think their modeling suggests that the cat's tail may have been the result of a dust production events just in the past 100 to 200 years. The reason they are using sporadic collisions instead of continuous collisions is that if you have continuous collisions, instead of having that nice streak going up from the collision point, you'd have a fan of material, and they don't see observationally a fan of material, so they think they have sporadic collisions instead of continuous. So in that lower picture then, the right-hand side, you're looking at the secondary disk from directly above. And so what happens is in the collisions, because of the radiation pressure and the interstellar medium drag, you get this material pulled out to the upper part of the diagram. The left-hand side shows the same model, the same calculations, but it's now oriented more as they believe we're seeing the secondary disk. And you can see that that arc of material going up in the right-hand side looks very, very similar to the cattail in the mirror image above. And so this is why they think this model is actually close to correct. So they basically conclude that porous organic refractory grains, the dark organic stuff, could explain the shape of the cat's tail, the mid-infrared color of the secondary disk. It also, the porous refractory grains explain the color of the secondary disk. It also explains the mid-infrared flux along the cat tail. Another reason they think it's sporadic collisions is that they have a rather sharp end to the cattail feature. If it was continuous, you would just see it slowly fade off into the background, kind of like the extended secondary disk on the other side of the image. Okay, so and the fact that all the porous organic refractory grains explains the fact that you don't see these features in scattered light. And that's because these things are very dark and they don't therefore scatter very much light. So you just don't see them. So the combination of all of this gives them high confidence that they have got a good model, at least for starting to understand the formation of this feature. And that's all I've got to say.
Awesome. Does anybody have questions? This is cool. I presume this is something they can watch evolve. It's probably not, if it's only a couple hundred years old, it might be something they can look at in a few years and see if it's agreeing still with their model.
I would assume that, and they do want to do additional observations, including spectroscopy, to help them understand the system.
Cool. Thanks, Wayne. Okay, so moving on to our members' Astro Images and Sketches. First is Chris Miskowitz. Chris, are you on? I didn't get much detail from him on the email of what he did here, but this, I think, was taken from Alpha Ridge fairly recently, as well as this one with a shorter focal length camera. I like that the framing with the Barnard loop in there. Next, Jim, are you on still?
Yep. So this was New Year's Day. Took the telescope out. It was better than expected seeing, and so I was able to kind of follow the great red spot as it traveled across the Jupiter's globe there as it rotated. It's one of the nice things about Jupiter is how quickly it rotates. You can easily kind of like within a period of 20 minutes, even visually note a change, especially if you got a big feature like the red spot going on. And you can see below the red spot a couple of storms. There's white ovals coming through as well.
How how many arc seconds wide is Jupiter now? Is it?
It's probably somewhere around the low 40s.
Okay, so it's still relatively, it's still relatively big.
Yeah, that's one of the nice things about Jupiter is that even as it pulls away from opposition, it's still so large that you got a fairly good sized target.
Nice, nice.
Could you please describe your equipment? Thank you.
Sure. This is a 10-inch reflector telescope. And basically, I'm using a Barlow 2.5 times Barlow as well. And then a video camera, a ZWO, the same folks that make the Seestar. They have a color video camera, and each one of these shots is probably about maybe 3 minutes of video, which then you use software to pick out the very best frames where the seeing was the steadiest and kind of pile them together into the end result here. So at a high level, that's how you do planetary photography, is called lucky imaging, where you take a video of it and grab the best video frames to bring together into your final image.
With 3 minutes, did you have to use WinJupos as well to derotate a little bit?
Yes, that's a good point. One of the software pieces that you use is WinJupos, which, because these are usually 60-second, 90-second individual videos, and I'll take like maybe 3 of them and use WinJupos to make a final image. And what WinJupos is doing is basically it's tweaking each one to kind of just how, like when you take a deep sky image, you align the stars. The WinJupos is aligning the features so that they don't come across as being smeared, over a 5 or 6 minute period of time.
It's awesome. Any other questions? Did that answer your question?
Yes, thank you.
Okay,
Sure.
great.
And then this was back in September. Neat little globular 6712, and in the same field, you have a planetary nebula there. So it's kind of cool when you can get 2 separate, disparate objects like that in the same field. This is with my 80mm Vixen, and about an hour and a half worth of subs, and then processing in PixInsight and Photoshop.
Nice. That's a much wider field of view.
Yeah.
Next we've got Wayne.
Yeah, this is M33 taken from Alpha Ridge Park with my 8-inch Ritchie Creation. This is LRGB for about 3 hours and 36 minutes total exposure time, as you can read at the bottom. So
awesome.
Weird.
And also,
And this is the Orion Nebula taken through narrowband filters, the typical sulfur H alpha oxygen 3 and the Hubble palette. The stars looked really funny because of the narrowband filters, and so I decided to remove them, and I liked the colors, so I thought I'd share this. Now, all the images were 4 minutes in duration. That's why the center part around the trapezium is completely blown out.
still super cool. It's abstract art here.
Yeah.
Thanks. And Jared.
Thanks. Can you hear me?
Yeah, I took a liberty of rotating this. It's so beautiful. Your normal aspect of how you look at this nebula is up and down, but I wanted to show the whole screen. So.
Oh, thanks. Yeah. So California Nebula. This is actually a picture that I finished here in January. What's interesting about this, that's a little different. This was shot with a color camera. The palette that you're looking at is your Hubble palette, like Wayne pointed out before, hydrogen, sulfur, and oxygen. What's interesting about that is that the filters that were used for the color camera, a lot of folks have been using the dual band oxygen hydrogen alpha filter that are pretty common these days that give you a nice like HOO palette. Recently, they've come out with filters that allow you to do the same thing for sulfur and oxygen. And so I shot this over 2 nights. First night with the hydrogen and oxygen filter, and then the second night with the sulfur and oxygen filter. And that allows you to get probably as close as I think you can get right now with a color camera to an actual SHO palette picture. And this really did a good job of bringing out the oxygen, which you see at the California Nebula at the top of the photograph. And I'm pretty excited about the different possibilities that these filters offer for color camera imagers. So just thought I'd share that with everybody. This was the ASCAR D2 filter. I know there's a couple folks out there in the Discord that have been using it. And I coupled that up with an Antlia ALPT filter, so they don't necessarily have to be from the same brand to accomplish that result.
What kind of camera did you use?
This was taken with a ZWO 2600 MC camera, which is an astronomy cooled camera. It's an APC crop sensor. So from that perspective, it's I think it's fairly common. You see a lot of pictures these days, I think, taken with that particular sensor.
Thank you.
Yep.
And it was 2 nights, so you collected
This is
several
yeah,
hours.
it's a combination of about 6 hours. And the way I stacked the data is actually I took all of the frames and stacked them together for 6 hours and extracted the oxygen, blue and green channels. And then it was 2 separate stacks of 3 hours for the sulfur and 3 hours for the hydrogen.
Awesome. So cool.
Yeah.
You're getting almost everything you can get out of that color camera with no.
It's pretty cool.
Yeah.
It's exciting.
And this is another one of yours here.
Yeah, this was the object of the month for the for December. Sorry, just trying to get caught up. So this is the Flaming Star Nebula. This was actually taken with a mono camera, same 2600. This was taken with SHO filters. I think it totaled up to about 9 hours of data in total, 3 hours across each narrowband filter. And this has not been. This is I got ahead of myself, put this out there. We have to finish collecting or tabulating our results from December to get the winning photograph over to Ken for the posting on the HAL website.
That's awesome. So you have a 2600 monochrome and a 2600 color?
I do. Yeah.
So you can do I mean, not that you have all this free time, but you could do a really cool study looking at the difference between, using those dual narrowband filters versus the single filters. That's awesome. I'm jealous.
Yeah, that was part of my objective, and I'll do some more posting on the Discord as I kind of get those results. In the past, I've been using the monochrome camera to just grab my sulfur and add it to my color camera's HOO stuff. So that's
I see.
the way I've been cheating in the past, but this
Cool.
is making it easier to use both my cameras at the same time.
Awesome.
Yep. Thank you.
And thank you for sharing. And then with regards to the object of the month, here's another submission on the same Flaming Star Nebula from Mark Parsons. Mark, are you on? He's another Discord user who submitted this. I think it's gorgeous. I like the three-dimensionality of how the oxygen is layered on top of the hydrogen stuff here. I don't know if I don't recall reading the image details if this is just HO or HOO or what, but it's pretty. And then to toot my own horn, here's my take at this same thing. So this is my version of the same nebula, and I also have an ASI 2600 color camera, and I used similarly an oxygen and hydrogen filter to get, you know, the H and the O part of it. And then for sulfur, I just used a narrow band sulfur filter on the color camera. So I wasted a lot of light. This is something like, but still, this was over several nights, and I have like 23 or 24 hours worth of data all added up. But again, you see that little blue stuff in there highlighting where there's oxygen. And I actually wound up collecting more sulfur than hydrogen. So a lot of this faint stuff is S2, I think. Anyways, last but not least, for sure, is Brad. Brad, are you on?
Yeah, I'm here, Victor, if you can hear me.
Yeah,
so
great.
this is a mosaic project I was working on from about August through November, I guess. Constellation Cygnus, a big section of it. It's 12 panels, all shot in narrowband and in a modified Hubble palette. So its total is like 72 hours exposure for the whole thing. I left the edges ragged. Nice. I want to add some more next year, but I ran out of time. So
this is stunning. I love the jagged edges are great because they let you see the mosaic.
Yeah, I kind of like that.
Yeah. So you've got the North American and the Pelican and the
Crescent. Yeah, what's actually kind of interesting when you do these mosaics is you find all these little things, like the one in the very top, slightly to the left. Yeah, I thought, wow, what's that? And one of the reasons I didn't chop it square, I would have cut that off. But then I went and imaged that separately, and you find all these little new things to shoot when you do these. So
it's
kind of fun.
Fascinating, man.
That's really cool, Brad. The zoom compression might be hiding it a little bit, but were you able to get the soap bubble near the crescent at all, or?
You know, I don't know if I looked. I'll have to go look.
Yeah, check it out.
I know what you're talking about.
It might be hiding in there somewhere.
Yeah, I'll have to go check it out. But it's getting big. The image, that full resolution is like 3.5 gigabytes at this point. So it's getting kind of large to deal with.
Yeah.
What kind of gear did you use?
It's shot with a Takahashi FSQ 106 refractor and a ASI or ZWO 6200 monochrome camera.
Thank you.
Sure.
Yeah, that's great. Okay, now I'm jealous of somebody else.
Well, I'm jealous of your scope too, Victor. So so it goes.
Well, that's fantastic. Thanks for sharing that. That's just gorgeous. And yeah, I think you can zoom in on this and look for that soap bubble.
Yeah, I'm gonna go check that out. Thanks.
Yeah, so thanks everybody. I think that's all we have for the meeting today, and we have only a few minutes left, and in the interest of not having the folks from the Robinson Nature here have to stay over.
Victor, just as we're laying out, I just would like on behalf of all of us club members, thank you and last year's board for everything you did, and congratulations on this year.
I appreciate that. Thanks. I really enjoy it. my family doesn't understand why I enjoy it, but I really enjoy it. All right, I'm going to stop recording. Whoops. How do I do that? More, right?